Welcome to the ET302 how-to video for the series Parallel Lab. Okay, we need to measure the voltage across each one of these, so let's grab some DMMs. Yeah, let's flip that guy. We may get some minus voltages, that's okay. This shows that we got the current going in the other direction. So we're going across the resistors here. And let's start. We got 1.76, 1.9. These should be identical because they're in parallel and they're the same value, so it doesn't matter. The voltage will be the same. The current's going to change if the value changes, but they're the same. So our current's going to be the same, and this guy. So if we add up 1.76, 1.9, and 8.2, you don't double add these, we should come up with 12. And I'm going to do some rough estimate, and it looks perfect. Okay, I cleaned up the circuit, and let's go ahead and do some current measurements. So let's bring back our DMMs. I'm going to measure current there, 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 and we're going to measure it there. Okay, so we need to break the wires, and we may get a negative current. That's okay. That means they have the meter in backwards. Okay, let's fire it up and see what we got here. This current okay, some of these are meters, so they're not going to read yet. So I've got a broken circuit here somewhere. So we need to convert these all to ammeters so we can start getting some reasonable readings. The voltmeter will mess up our circuit. Okay. Okay, so we have, here's our circuit and battery, so we're going to have the current going and coming, and they're going to be the same. So our circuit here at the battery, current's going to be the same, so we're flowing back in here. Okay. And we need to actually, this is the current going into this pair. This is the current of this resistor, so let's add one more meter. So we're going to get this branch. We're going to get both branches, and being that they're the same resistance, we should have the same current, and we do. All right, since resistors are the same, the current's going to be the same. Okay, here we're having these two added up, going through this resistor, because these two are series, so they're going to be the same. Okay, so if I take this 1.76, it should be equal to these parallel. So if I add these two up, it should equal that. So this resistor and this leg here should be the same resistance, same current. Sorry. Okay, so this is what we have. Okay, let's build our light bulb circuit. So we're going to go over to here, and this is our indicators, and I'm going to choose a 12 volt 25 watt, and this will be 1, this will be 2, this will be 3, and this will be 4, and we're going to go back to sources, and we're going to have DC power, our battery, and it's still 12 volts, and we're going to find a ground. Good. Okay, so we're going to rotate these guys 90. Alrighty, so let's build our circuit. Alright, so I'm going to show you a feature of Multisim here. We've already used our DMM, so I want you to understand how to do that, but we could utilize probes. And we want, when we put these in, the arrow is going to point to the direction of current. Nope, just direction. Come on. And let's just put him down here and start it. And let's zoom in, zoom area. Okay, now if you look here, we have 833 milliamps out of the battery, 33 milliamps returning to the battery, depending on which, if you're using conventional or electron flow, but essentially coming and going. And we have 417 milliamps and 417 milliamps. So these two, if you add them up, they're going to be 833. So being that the current is less in these bulbs, it's going to be dimmer than these two. I don't know if it's linear. I don't know if they're going to be twice as bright or dim, depending on which ones you're looking at, but they are going to be dimmer.